That's how I learned it. Basically, it's the time that it takes to paint all the things that you can't even see. And anytime a client asks you to write that code, stop them and explain to them what I just said, because that's going to make it slower. And if you want to render 1,000 rows or 10,000 rows, and that's what they want to show, then you ask them, but they can't see all that.
So I applied to a job last year. Unfortunately, I didn't get it in the end. But there in the take-home challenge, there was like one section where it's about to render a very large data set. Like really, it was huge, a huge data set to the DOM. And they wanted to see you doing it in a very efficient way, right? And virtual scrolling came directly to my mind, but they said, no, like virtual scrolling, it's not the way, or it's like not allowed, or not what they are looking for. Yeah, what other options are there? I mean, what I ended up with was like rendering everything, and then when you before resizing the browser, I would remove all the, like if everything rendered, when you would resize the browser, the window, it would be very laggy. So what I ended up with was just rendering everything, and on resize, remove everything from the DOM, and on resize stop with like, of course, some bounce or debounce, I would re-add it. And that kind of fixed the immediate performance issues. But I mean, of course, that's not the way, right?
That's an approach I've not heard before. Yeah.
But I mean, it worked. But,
yeah. I don't know. I'm not an expert in those kinds of interaction patterns. I know virtual.
Can I take a crack at this one?
Yeah.
Okay. So from an application perspective, the reason why it takes so long is because the DOM has to paint everything all the way down to the bottom, even when your user can only see 20 rows, which really doesn't make any sense. So if your user can only see the top 20 cards, and yet you want to paint 9,999 cards, then it doesn't have anything to do with Angular. It's actually the browser that has to render that all the way down to the bottom. And every time you change something, it's going to start over. And that's where you see the lag. And so no matter what your code looks like, no matter what Alex does with Angular, or no matter how clean and perfect you write it, if you're trying to render 9,999 items on the page, it's going to be slow because of that. And that's why when you first started talking and you were saying virtual scroll, and I was like, yes, that's the right answer. Don't render all that stuff, right? Yeah, so that's how I learned it. Basically, it's the time that it takes to paint all the things that you can't even see. And anytime a client asks you to write that code, stop them and explain to them what I just said, because that's going to make it slower. And if you want to render 1,000 rows or 10,000 rows, and that's what they want to show, then you ask them, but they can't see all that. Why are we painting it? It's going to take forever. Not a good idea. Would you agree, Alex?
Yeah, definitely. Specifically around the diagnosis too, like the reason that gets laggy, right, in the resize event is the browser, every time the user moves the mouse a little bit and like changes the size of the window, the browser has to do a reflow, right? It's like, well, my constraints are different for the boxes that I need to paint, so I need to go and like figure all this stuff out again.